in probability for a certain event E, so the possible outcome which satisfies the condition, we call it favorable outcomes. And then for example, like when you throw a dice, so totally there should be totally 6 possibilities, so which are 1, 2, 3, 4, 5, and 6. So for example, the event E you are talking about, you want to get even numbers. So that's why you will see they are 2, 4, and 6. For example, the event F and I event, you want to have prime numbers. So that's why the possibilities will goes to the favorable outcomes will be going to 2, 3, and 5. And the next, the definition of theoretical probability, and then which is called, you will see on top, you are talking about the number of favorable outcomes, while the bottom will be the total number. So what do we mean by the number of outcomes? So somehow I will interpret as is something you want to achieve. For example, when we are talking about even numbers, the probability of this event will be, first of all, at the bottom, it should be the total number of possibilities, which means it's 6. You remember that there are 6 outcomes over there. When you want to get even numbers, so that's why you have 2, 4, and 6, and there are 3 possibilities to get the favorable favorable outcomes. So coming up next, you simplify the fractions and you get 1/2. While for the other event called PF, which you want to get prime numbers, the total number of outcomes at the bottom will be the same, which is 6, while on top, now you've got 2, 3, and 5 as your prime numbers. So that's why the results will be still 1/2, though the events are different to each other. So let's see whether you can get the idea that for probability, so it should be between 0 and 1 inclusively, or in mathematical equations or not equations expression, so we write as 0 is less than equal to PE, probability of an event is also less than or equal to 1. And then next, you can have some wordings to explain these two extreme situations. One is, if you got PE to be 0, that means it's 0 chance to get it, which we call impossible event. While PE is 1, it's like 100%, and that's why we call it a certain event. So the concern about the probability, which we just talked about right now, it should be between 0 and 1. And then so in one of the past paper in 2006, and you will see which of the following could not be, could be the probability of an event. Now you can check from the calculator. For A is 1 point something, B is 0.999 something, C is negative, you will see, while this one of course is greater than 1 already. So according to probability that it can't exceed 1, so that's why number 1, number 1 part A and answer D, they are wrong. While probability can't be negative, so that's why C is wrong, it gives you the answer of B. Next, we come to take a look in number 6 to see how we get the probability as follow. First of all, you will see the fair coin is tossed 3 times. 3 times, that means totally how many results are there. So you can use the idea of tossing a coin 3 times, that means each coin or each time there are 2 possibilities. So that's why the total possible outcomes will be 8. So as a result, in order to answer B, you should know that the denominator should be 8. We will be talking about it later. But now when we go back and follow the question, and you are asked to use a tree diagram to list out all possible outcomes. And let's see whether you remember how to do it that you learned in last chapter. So first of all, you have head tail, and then so you have head tail for the second outcome, and you continue to draw the branches to each possible outcomes. And this is your tree diagram required in part A. And then next, for part B, you are asked to find the situation of getting 2 heads and 1 tail. And then normally we will start from answering the question called required probability. And first of all, you get an 8 already, or you can count it in this way, like 1, 2, 3, 4, okay, 5, 6, 7, 8, etc. And then now among 8 of them, okay, let's go back. Among 8 of them, how many of them is 2 head and 1 tail? You can highlight 2 head, 1 tail first time. This one, 2 head, 1 tail second time. This one, 3 times. So that's why you have 3 as your favorable outcomes. And that's all for example 6. Another one which is even simpler would be example 7. And then as my habit, I would be writing the total number of the outcomes first. You have 2 red, 3 blue, 4 green, totally 9 results. Totally 9 results. One ball is drawn from the back, and you want to know the probabilities of. Okay, first of all, part A. So I write as required probability, totally 9 balls to be drawn, and 2 of them are red in color. So that's all for part A. Very easy, right? Well, for second one, the keywords will be and. And means, can you get a ball having red and green at the same time? Definitely not. So that's why you can simply saying that the required probability is 0, yes, because it can't happen. But what if I give you another question called C, called red or green? So if we change the connective first simply, and then so it gives you a totally different answer. Because red or green, that means you can get a red one or blue one as your favorable outcomes. So that's why the required probability will be equal to, this time totally you have 6 favorable outcomes, 2 red and 4 green possible choices out of 9 as a total. So that's why it gives you 2/3 finally. So in this simple question, so bear in mind that so it would like to tell you the difference between and or in the question. One thing you will find it hard in doing probability question because it is integrated with some math sense, because you're not familiar with like the keywords like even number, multiple of 5, even or multiple of 5, etc. So but anyway, well, let's start from reading a question one by one. You're choosing a number, an integer from 1 to 50, and you are asked to do the following. Okay, first of all, part A, so required probability. Okay, because now you're talking about 1 to 50, half of them is odd, half of them is even. So if you're smart enough, you can just write 1/2. If you can't manage in this way, then you can list out even numbers. There are 2, 4, 6, 8 until 50. And then you may count the numbers one by one, or you can use your own way to see how many even numbers from 2 to 50. So you will see that there are totally 25 numbers are there out of 50 of them in total. So that's why it gives you 1/2. Well, for part B, so you can do a similar thing, because multiple of 5, that means 5, 10, 15 until 50. So you can also use your own ways to find out the number of multiples over there, and which now you have totally 10 of them, right? So 10 of them out of 50, they are multiple of 5. So that's why it's 1/5. And finally, that's the keywords I would like to highlight in part C. It's called even or a multiple of 5. In this case, you can count it once again, and so you will see that actually we do some we will have this something beforehand, because even number, so you have 25 of them, multiple of 5, so there are 10 of them, so you are supposed to have 35 numbers, isn't it? Definitely not, because when you talk about either one of them is okay, 25 and 10, but if you have to check very carefully, are there any numbers which are duplicated? Yes, you will see that actually the number 10, the number 10, the number 20, 30, 40, and 50, they are duplicated. Okay, see it? So as a result, when you add 25 and 10 together, actually you count these 5 numbers twice. As a result, we need to minus 5 finally to get the situation of part C. So that's why part C requires you to do something about addition and subtraction carefully, which you have 25, 10, 35 numbers from part A and part B, in which 5 of them are double counted out of 50 numbers in total. And this is the situation of even or a multiple of 5. So as a result, the outcome would be now, after cancellation, is 3 over 5. How about we add a question in part D called how about if we are talking about the probability of event, the event is like even and multiple of 5. So in this situation, when you have even and multiple of 5, that's exactly the 5 numbers I just mentioned. So that's why there should be 5 numbers out of 50 and gives you 1 over 10 only as the answer for part D. Next, we come to another part you may find it a bit weird when you study in junior form, which is called experimental probability. So is it really talking about experiment? Not really, in my understanding. So let's go back to the previous probability that you use it very often. Theoretical probability. So what does that mean? Theoretical. Actually, it's talking about it's like every event carries a equal chance to happen. For example, when you throw a dice, 1, 2, 3, 4, 5, 6, 5, 6. So these 6 numbers, they have equal chance to appear. So that's why for each number, for example, if you want to get 1, the probability will be 1 over 6. If you want to get 4, so you also have 1 over 6 as well. That's what do we mean by theoretical probability. For example, like when you toss a coin, then you may have head or tail. So each side has the equal chance to appear. So that's why if you want to get a head, it's 1 over 2. If you want to get a tail, yes, it's still 1 over 2. So this is a situation of theoretical probability. But in reality, there are many situations, examples that the probability of certain event may not happen in the same way, in the same chance. For example, I'd like to ask, for example, sunny day, cloudy day, and then rainy day. So generally speaking, there are like three kinds of weather that you may have tomorrow. Does it mean that tomorrow there is 1 over 3 chance of having rainy day, 1 over 3 chance of having cloudy day or sunny day? So if you think in this way, it's definitely wrong, because weather is not, we don't have equal chance in talking about the possibility of weather. So for example, in Hong Kong in winter, so normally we will have sunny day, maybe cloudy day. We rarely have rainy day, and so sunny day should has a greater chance to happen, right? So maybe in summer, rainy day will be more chance than winter, for example. So then in different countries, different places, sunny, cloudy, rainy, they have different possibilities, probability, right? So that's why in this kind of question, we'll call them experimental probability, because we don't really have the same probability to each situation. And then, so normally in experimental probability, there should be some keywords or some hint for us to consider. For example, like it's very likely the question will be mentioning very clearly experimental probability, as well as there may be a table given to you. And we quickly jump to like next example. Can you see that there's a table, as well as the question indicate experimental probability very clearly. So that's why we go back to this question as follow. So it's about like kind of quality control, quality assurance. When you're talking about eggs, there are 40 cartons of egg sold in supermarket. You are talking about crack or not crack. I think you don't think that is chance of 1 over 2 and 1 over 2. If you do say yes, that means when you buy a pack of eggs, like 18, so generally speaking, there are 9 of them are cracked. Do you think that it makes sense? Of course not. So that's why crack or not crack for a pack of eggs, there is definitely not theoretical probability or equal chance. And then so you will see the situation. So in 40 cartons of eggs over there, so no crate eggs, there are 16. One crate will be 10 cartons, etc. Anyway, now you will see this is called number of cartons here. You will see that it's the frequency. So that means it's something about we are talking about total. Now totally how many cartons of egg you are considering? Yes, they are totally 40. So this is the denominator we are going to be used. As a result, when in part A, we say it's called required probability. At the bottom, in the denominator, is 40. In order to have no crate eggs, there are 16 of them. Pretty easy, right? Yes, I think it's very easy to you. While in part B, when you are talking about fewer than 3 crate eggs, so we have 0, 1, I show it in this way. That means it's talking about 0, 1, 2. Shall we consider 3? No, because we're talking about fewer than 3. On the next, so you have 16, 10, 7. So 16, 10, 7, they are your favorable outcomes. Out of 40 of them, which gives you 33 over 40 for part B. Not very difficult, hopefully to you. Okay, so next, example 12, I just casually talk about the question because dice may not be fair, so it may be like load dice or unfair dice. Sometimes you will see this word, and unfair dice. That means the probability of the appearance of each number is different. For example, you will see that the dice is specially made so that the 2 will appear more often, obviously, significantly than the others. So in this case, you can't use 1 over 6 to talk about the probability of getting a 2. And answer is wrong, because now it's a load dice. In this case, then you have to read the table and remember, experimental probability carefully. So by the way, I leave this question to you. And then another kind of experimental probability will be like hitting a certain region, or like you're talking about a dartboard. So this question I embed the idea about similar triangles together, so that you have to remember something about ratio. Now Andy is going to throw a dart, a random to hit the board. You want to hit the green region. Okay, first of all, you will see that ACDF, ACDFGI, so the length of each triangle, they are 7, 5, and 3. So that's why when you're talking about area of big one, it's called triangle ABC, to area of triangle DF, to area of triangle, the last one, which is called GHI, and you remember how to get it according to the ratio of lengths. Yes, that's good. So it's about square. So 7 square, 5 square, and 4 square. Don't forget it, because it's also a very frequently asked question in your paper 1 in your examination. It's 49, 25, and 16 finally. And then next, you will see that 49 is the biggest triangle, right? So that means it's the total possibilities. And then as a result, when you're talking about the required probability, so 49 will be the total possible outcomes, though it's not really talking about it's 49 cm square, but 49 is total. And then you are talking about hitting the green region. The green region, you will see that it composed or is defined by DF minus GHI. Is DF minus GHI, so 25 parts minus 16 parts. Then by calculator, you get 9 over 49 finally. And then at last, I just pose a question. How you can judge the question is about experimental probability? Do remember 2 things I just mentioned to you right now? If yes, that's good. Then you've got the basic idea about probability in this session.